Good afternoon, everyone. Welcome to all of you. Welcome at Exampur English Medium Prep. Today, we are here to discuss the questions based upon the general physics. Okay, these questions are the most probable questions which can be asked in your examination you are focusing on. That's why I will suggest you to just write down all these questions sequence wise on your notebook, so that whenever you go for the exam, then you must revise all these questions. I will explain all the concepts behind the questions. First of all, before starting, please subscribe this channel and press the bell icon button, so that whenever I and my team come online, then you can get the notification from our side. So good afternoon. My name is Kumar Ravi and I'm going to discuss the questions on general physics. So see, the first question on the screen is unit of force. Actually, here we are talking about the unit of force. It means SI unit of force. SI means International System of Measurement. Okay. When you will see all the options given here, you will see that all the options are from three options are from MKS and one option which is ERG. This is a CGS unit but not of force. Okay, so the unit of force is very simple and the correct answer is Newton. Okay, so first of all we should know about that 1 Newton. How can we write the value of 1 Newton in terms of kilogram, meter and second? Let's know. We all know that force is equals to m into a, where F is the force, m is the mass of the body, a is the acceleration of the body. So the mass of the body is kilogram, into a is the meters per second square, and this is known as Newton. This is known as Newton. Okay, this is known as Newton. So here we can write it as kilogram into meter per second square. This is Newton. Okay, so here the option is option B is the correct answer. Now let's move the unit of work. When we talk about the work, we talk about the unit of work. Okay, without any unit, without writing any unit, you cannot define that I have mentioned this physical quantity. Suppose that I have written I walked 34, but what 34? Meter, kilometer or centimeter or joule? If I will mention the unit, then I will define that I have written this physical quantity. Okay, so here the unit of work is joule. Actually, joule is written like this. Joule. First of all, work. We will write it as work will be equal to force into displacement. Force into displacement. Okay, so it means force. This is Newton into meter. Newton into meter, and this is known as joule. This is known as joule. Okay, this is known as joule. So we can write it as 1 joule equals to 1 Newton. 1 Newton multiplied by 1 meter. 1 Newton is 1 joule equals to 1 Newton into 1 meter. It means 1 joule of work can be defined as if we apply 1 Newton force on any body and the body get displaced by 1 meter, it means we have done 1 joule of work. Okay, so the unit of work is joule. It's clear now. We will move to another question. The unit of tension. This is a very important question because it was asked in the SSC CHSL a few years ago, but most of the students, they were not able to give the correct answer because the term tension, they have never heard. Those students who are not from the science background, they have never heard about this word tension. Actually, tension is a force. Actually, tension is a force. Okay, because suppose that if we talk about a string, suppose that, or this is a rope, this is a rope falling on the ground. Okay, there is no tension in the string, but when we just pick that rope and just tie with a wall and just pull it like this rope turned like this rope turned like this, and in this form some tension is arised in the, some tension is generated in the string, and tension is mentioned always in terms of like this, in by t, okay, by letter t. Okay, so tension is generated, tension is produced by applying the some force, just because of the force. That's why this force is the responsible for the generation of the tension. That's why the unit of the tension, that's why the unit of the tension will be the force. This is Newton. This is Newton. Okay, this is Newton. So here the unit of the tension will be Newton. Okay, clear. Unit of surface tension, the unit of surface tension, unit of surface tension. I have explained the tension in the string, and that is the linear tension. Actually, here we are talking about the surface tension. When we talk about the surface tension, then it means something else than Newton. Okay, obviously, actually surface tension can be defined as, the force upon length on any liquid surface. Force upon length on any liquid surface. This is known as surface tension. This is known as surface tension. The unit of surface tension will be equal to, force means Newton, force means Newton, length means meter, length means meter. Okay, Newton per meter, Newton per meter, and the C will be the correct answer. C will be the correct answer. Okay, so unit of gravitational constant, unit of gravitational constant. Okay, unit of gravitational constant, unit of gravitational constant. Okay, first of all you should know about the gravitational constant. What is the gravitational constant? Dear friends, when we talk about the gravitational force acting between the two bodies, Newton has told that any two bodies in this universe attract each other like this, like such that this is a remote control and this is a pen. Okay, this remote control device and this pen will also attract each other. Okay, these are actually attracting each other, but the force of attraction is very very low. That's why we cannot even feel that these, both of these bodies are attracting towards each other, or these are approaching each other. Okay, that's why gravitational force is a very weak force. This is the reason that we cannot realize the attraction pull between these two bodies, but a force acts between any two bodies in this universe, this is sun, like this is sun, and suppose that this is the orbit of earth, and this is the earth, this is the earth, and an attraction force between sun and earth exists, and this attraction force is known as gravitational force. And this gravitational force depends upon, the value of gravitational force depends upon the masses of these two bodies and the distance between these two bodies. So the gravitational force, formula for gravitational force is equal to capital G into capital M into small m upon r square. Okay, so this is the force. So this constant, this term capital G, this is known as the gravitational constant. Actually, F is the gravitational force, M is the mass of the body, Small m is the second mass of the body, r is the distance between these two masses. Okay, so here we can write it as capital G is equal to F into r square upon capital M into small m. It means simply we can write it as unit of force is Newton. Unit of force is Newton into r means meter square. R means meter square upon this is kilogram square. This is kilogram square. Okay, Newton into meter square upon kilogram square. So this is the correct answer. Newton into meter square per kilogram square. Newton into meter square per kilogram square. Okay, so B for Bombay is the correct answer. B for Bombay is the correct answer. Raindrops are spherical due to. Raindrops are spherical due to. Raindrops are spherical due to. Okay, cohesive forces, adhesive forces, surface tension, viscosity. Cohesive forces. What are the cohesive forces? First of all, you should know about the cohesive forces. Cohesive forces in physics, we define the cohesive forces, the force of attraction between the molecules of same material in liquid state. When a material is in liquid state, then the molecules of that material in liquid state, they attract each other and get connected. And this attraction force is known as the known as cohesive force. But in chemistry, the attraction force between the same material molecules is known as is known as by the different names, just because it depends that what kind of material, what kind of molecules actually they are. Just like when we talk about the water molecules attract each other, and this attraction force in chemistry is known as hydrogen bonding. But we will talk about this, we will call it as cohesive force, because these are the same material molecules. Okay, like any molecules, any metals, if we take any example of any metal, like any just like iron, iron, aluminum, or anything else. Okay, then the attraction force acting between the molecules or atoms of any metal, and this force is known as metallic bond in chemistry, but in physics this is known as cohesive force. Okay, so cohesive force is the force acting between any two molecules, or any between the molecules of same material. Okay, and this is the reason that when two ice cubes or more than two pieces of ice cubes get connected, when they come to each other, when they come in contact each other. Okay, so this is an example of the cohesive force. Now adhesive force, when we talk about the adhesive force means the attraction force acting between the molecules of different materials. Just like I write on whiteboard by a black marker in my offline classes, then the attraction force between the black ink and the board, and this is known as what? Adhesive force. Okay, I just do paint on my walls, the attraction force acting between the paint and the walls, and this is adhesive force. Adhesive, it means anything that is responsible for the sticking of any two materials, any two different materials. Okay, that is the adhesive force. Surface tension, here is, this is the correct answer, because surface tension, due to surface tension, any liquid having surface tension always try to minimize its surface area. In mathematics, it has already proven that the minimum surface area is acquired by the spherical surface only. Spherical surface. For the given volume, the minimum surface area is acquired by the sphere only. Suppose that I have given you a wet sample of soil, wet soil sample. Okay, and then I have asked you to make a toy, so that the painting expenses of this toy is very low. First of all, you have made just like this, it means like cuboid shape, and you have just calculated the total surface area of this cuboid toy, and then you have mentioned in your sheet, and then after you have just converted this toy into a cubical shape. Okay, then after you have calculated all the six surface area and then mentioned in your sheet. Now you have turned you have changed this shape into a cone shape toy. Okay, you have calculated the total surface area. Now at last you have just made this spherical, and you have calculated the total surface area of the sphere. Now you have mentioned on your sheet. It means the minimum surface area of the toy is of sphere, but the volume of the toy is same in all the cases, because the material is same, quantity is same, density is same, everything is same. That's why we can say that the minimum surface area for a given volume, minimum surface area is required by the sphere. And we all know that due to surface tension, every liquid tries to minimize its surface area. If a liquid will try to minimize its surface area, it will become spherical. And this is the reason that raindrops are always spherical in shape, just because of surface tension. Okay. So first law of motion is also known as and this is a very simple example. Actually, law of motion was given by Isaac Newton, but the law of inertia was given by the Galileo. Okay, so first law of motion is actually also known as, or is based upon, the law of inertia. So A is the correct answer. Actually, this question can be written it as first law of motion is based upon the law of inertia. Okay. Unit of electric current, and this is the very simple example, and ampere is the correct answer. Coulomb per second. This is equal to ampere. Okay. Rate of flow of charge, this is known as electric current. Okay. Rate of flow of charge, it means the charge flow in unit time. Now, unit of electric resistance. This question has already been asked in different exams. Okay. Unit of electric resistance is ohm. Okay. Unit of electric resistance is ohm. This is the correct answer. Rate of change of linear momentum is equal to rate of change of linear momentum means delta P upon delta T. I will explain this in the laws of motion. Already, even though I have already explained this topic in physics, and you can watch my video lectures on the same channel. You are watching this video live. Okay, so this is the example of force. Actually, this is equal to force. Okay, so rate of change of linear momentum, this is known as equal to the force, value of force. Unit of moment of inertia. So please give me the correct answer. Let me see your comments. Is there any query? Then you can write me. If you have any problem, any query, then you can write me in comment. Nikki, good afternoon. Subham Upadhyay. Hello, Subham. Great. So, moment of inertia. Moment of inertia is described as I is equal to mr square, where m is the mass and r is the meter. Kilogram into meter square. So this is the correct answer. Okay, kilogram into meter square. Okay. On moving above the surface of earth, weight of man when we go above the surface of earth, the value of gravitational acceleration decreases. Value of gravitational acceleration decreases. Suppose that if a man is standing here and now this man is pulled and placed at this place. Obviously, the value of gravitational acceleration here is g, and the value of gravitational here is g dash, which is less than g. And we all know that weight of body, this is equal to m into g. It means if the value of g will decrease, then weight of the body will also decrease. Okay, so on moving above the surface of earth, weight of man decreases. B part. On moving above the surface of earth, atmospheric pressure, when we talk about the atmospheric pressure also decreases when we move above the surface of earth, decreases. B part is the correct answer. Okay, weight of man is maximum. Now this is a very good question actually, and this question has already been asked in many examinations many times. Okay, so this is pole and this is north pole, suppose that, and this is south pole and this is equator. Okay, when we talk about the weight of the man depends upon the radius of the earth. Actually, radius of earth is not constant everywhere. On equator, radius is maximum, on pole the radius is minimum. Value of g is inversely proportional to the square of radius of earth. So where the radius of the earth will be minimum, the value of g will be maximum, and the weight of the body will also be equal to maximum. So the weight of the body will also be equal to maximum. So here we can say that the weight of the body will be equal to will be maximum at poles, because the radius of the earth is minimum at poles. Where the radius of the earth is minimum, gravitational acceleration will be maximum, and hence the weight of the body will also be maximum. Okay, so again, weight of man is minimum. I have already explained that W is equal to m into g. When the value of g will be minimum, the weight will be minimum. G will be minimum where the radius of earth will be maximum. It means it means equator. Okay, so A will be the correct answer. Okay, weight of man is zero. Tell me what is the correct answer. Where the weight of the man will be equal to 0. We all know that at the center of earth, weight of the man is equal to 0, or weight of anything will be equal to 0 at the center of earth. So C will be the correct answer. Weight of the man is maximum. Okay, this question has been repeated. If the rotational speed of earth increases, then the weight of the man on earth will decrease. Actually, the effect on the gravitational acceleration, effect of rotational speed on the gravitational acceleration is like this: g is equal to g minus re into omega square cos square theta. So here we can say that if omega increases, this whole quantity will increase. If this whole quantity will increase, this quantity will decrease. It means this quantity will decrease. It means B option will be the correct answer. Okay, so B option will be the correct answer. Now, rope of lift breaks. Unfortunately, man is standing inside lift will experience his weight equal to 0. When the lift starts falling freely, everything inside the lift will experience 0 weight, and this condition is known as weightlessness, and this situation is known as free falling. Okay, free falling. This is a case of free fall. Okay, it means free fall. It means weightlessness, simple weightlessness, ठीक है ना. We will write it as W will be equal to 0. W will be equal to 0. So if the rotational speed of earth increases, then weight of man on earth will. If the rotational speed of earth increases, then the weight of the man will decrease. Obviously B part will be the correct answer. Okay, velocity is a velocity, actually velocity is equal to displacement upon time. Displacement upon time. Displacement, this is a vector, hence the velocity will also be a vector quantity. Okay, so this is a vector quantity. So this is a vector quantity. Guys, today actually I'm not feeling well. I'm suffering from the cold and fever right now. There are many questions to be discussed, but I will stop this session today here, and I will continue my session tomorrow at 2 p.m. Okay, and tomorrow at 2 p.m. I have an marathon class, and you will see my event in the same channel. Please do like and subscribe this channel and share these videos. Okay, thank you so much. Have a nice day. Bye bye. Take care.